So here's the circuit. The manufacturer's numbers on the uh, photoelectric sensor are right. So pin 1, that's your brown wire. Uh, Pin 3, that's your blue wire. And then pin 2, that's the black wire. On the lamp, we're using 1 and 2 on our lamp, which is the red lamp. Okay. So I got the circuit wired up. So let's look at on the camera. Very similar to those circuit, except it's a 3-wire sensor instead of a 2-wire sensor. So that means we had to run, the brown is running and connecting directly to L1. And then this green, this is running directly, in the green wire, which is the blue wire on the sensor, is connected to L2. Then we also got L2 going over to one side of our light, over to 2. And then this right here is my ammeter. So this would actually be the black wire running from the sensor. But this is my ammeter hooked up here. Okay. So we're pretty much well going to do the same thing here, but this thing here don't detect metal. This is we'll start off by using it as a diffuse sensor. And what does a diffuse sensor do? How does it work? It works off reflective light, right? So my gloves are black. Will it pick these up? Yes or no?
No.
No.
Well, you got to understand there's no perfect blacks. So this is reflecting some light. So yeah, it'll pick it up, but I'll have to be real close. So I don't know if I can. Let me go around to the other side. I'm going to have to get up out of my wheelchair. I might need to turn the sensor around. So here I come with my black, and y'all tell me when it picks them up. Right there. So see how close I have to get it? What, about 2 inches before it picks up the black? Now, if it's white, which is highly reflective, it picks it up right there, which is probably around, about 6-7 inches. So yeah, it'll pick up black. If it didn't work, the Festo line wouldn't work, because the Festo line has black cylinders on it. And it has to pick up those. We just have to adjust them so it does. So yeah, it'll pick up most colors. If I had pure black, odds are it wouldn't pick it up, but really there's no such thing as pure black, guys. So yeah, it picked up black, but I had to get what? I was in between what? About 2 inches, right? Okay. So without using a reflector, place your hand in front of the photo sensor so it turns on. What type of scanning method is already used? We already know that. It's what? What type of sensor is this?
Diffuse.
Right, diffuse.
Diffuse.
Right, so this is a diffuse sensor, right? So that's number 7. Oh, we'll have to guess on the inches, guys. I don't have a ruler in here, I don't think, but we can pretty much guess. So without using a reflector, place a black sheet of paper in front of. I don't have black, but my gloves will be okay. I can use this, and I'll have to go around to the other side. So what I have is I have a black toolkit. So this will be our black piece of paper. And we'll guesstimate the inches. I think we already did that. Without a reflector, place a black sheet of paper in front of the photoelectric switch so it turns on. Determine the maximum distance the paper can be away from the photoelectric. So it is going to turn on, right? Y'all understand that? It is going to turn on. So here it come with the black. Y'all gonna have to guesstimate it. We're watching when the light turns on. Right there. So about that.
1 inch.
About 1 inch. Okay. Then it says in the lab for me to do a white. So I got this white right here. So about 1 inch, but it did pick it up. Let me find a good white portion of this right there. And we'll start moving it in. And we're waiting on the light to come on. Right there. So what's that? Can y'all take a gut shot at that?
About 4 or 5 inches.
About 5,
Yeah,
6
4 or
inches.
5 inches.
Okay.
4.5.
4.5. There you go. Thank you, Tucker. 4.5 inches. So the lighter the color, the further we can be away from it, right? So, and that's without a reflector. So it's reflecting off the side. This is actually a diffuse sensor. So about 4.5 inches. Why did the white paper have a different range than the black paper? Because white is more reflective than what? Black. And diffuse works off reflective light, not reflected light. And so the darker the color, then the less light we'll get back in the range. So we could use this to actually approximate range. Y'all see that by when it switches, so or color. Measure the supply voltage across. Measure the supply voltage across the proximity switch, and voltage across the lamp. So we're going to start off with them both off, right? And I can use my light, I can use my glove to turn these things on. So we'll measure it across the proximity switch with the load off. So we're back over on the green, on the yellow, and I don't know what I'm doing. So voltage across, we're going to measure, let me move it over. I don't think, let me set this one off to the side. Move it here over so I can shift my Okay, so I've got it on AC volts. I got it on 400 volt scale. We're measuring the voltage across the line, right? The line voltage. Is that right, everybody? I can't see this. So here's the line voltage. I can go from 1 to 3. So it should be about 114.5, which is what we probably measured last lab. Okay? So what's our next voltage measurement? Or am I measuring these right? What was the first thing I was supposed to measure?
Voltage. Load off.
Yeah, across the switch. So this is across the switch. So this will be from L1 to 2. So this is A, 114.
The video ain't on, Rick.
I I didn't turn it off. Hold on.
There you go.
Okay.
That's it.
All right. So y'all should have told me. Was it on when I was going over the circuit?
Yeah, it was on when you were going over the
I
first
must have
time.
accidentally hit something. Okay. So we'll do the first one again. A, I'm measuring the voltage across the proximity switch with the load off. So I'm going between 1 and 2. $114.5. Everybody okay?
Yep.
Then this is with the this is with it on. That's next, right?
Yeah, with it on is next.
$2.5. It's a lot less than the other one. The other one was 4.6 because this one's powered. So even though these things are solid state and they never can drop 0 volts, they'll always be a leakage current when they're through, and they'll always have to drop a voltage. So this guy right here is dropping what? Around
2.5.
Yeah, about 2.5. So in a 120 volt circuit, that 2.5 volts wouldn't mean much, but on a 24 volt circuit, and you try to hook a bunch of these up in series, that would really be costly, right? You'd get to a point where it would not bring in your load anymore. Y'all know what I'm talking about. So each one of these things, if they're solid state, these guys right here drops 2.4 volts. And I've got all these proximity sensors out there. I'm just going to draw them as timers. And I need to put I need to do AND logic with them. Well, they're dropping 2.5 volts. This will drop 2.5 volts. This right here would drop 2.5 volts. This right here would drop 2.5 volts. So them suckers right there would be dropping 10 volts. I'm over here bringing this into a PLC or into a relay, and instead of having 24 volts, I got 14 volts, and my relay won't even pull in. Right? You understand that? So what would we do? What would we do? Well, what we'd have to do is we'd come over here and we'd take each one of these, and then we'd send it to a control relay. So instead of doing it like that, we would do it like this. Control relay. And then down here in my actual logic, I could put as many contacts off my control relays as I needed, right? So if you had to do this, then the only option you got is to let each sensor pull in a control relay and then use the contacts of the control relay to do your logic. So y'all see what I'm talking about? So this could cause a problem with solid state. Normally solid states control relays anyway, or they go into a PLC. And a PLC, this would make no difference, because a PLC, what I would do is I would assign, each sensor would be assigned to its own input anyway. So what we would do is each sensor would be assigned to its own input. And then inside my control logic, when I programmed it, I would program it like that. So PLCs, it's no big deal about hooking things, because the inputs go up to each one of them has their own input, and then you program the inputs how you want them to work. But in relay logic, we got to be real cognitive of think about when I start using these solid state relays, how many that I'm going to be using, right? Y'all understand that? Yes or no? PLCs, we don't care. I could have 50 solid state sensors, because we're not hooking them in series. We're not hooking them in parallel either, too, guys. But we've come in and because each one of them will go into a different input.
Oh man.
Okay, so what's our next measurement? So we need to measure with it across with it on. We just did that, right?
Yeah.
All right, let me bring the lab back up.
Now you gotta go across the load.
Now we got to go across the load with it off. So my load is my lamp. So this is voltage across the load with it off. So what do we anticipate?
0.
Close to, but it's going to be a little bit with solid state sensor because of the leakage current, right? So we'll come up here,
Right.
we measure across the load, and see it's not quite 0.
Right.
Now I've got it on my 400 volt scale, so if I'm measuring according to what I'd be measuring anyway, if I'm measuring 120 volts, then it's going to measure 0 because I have to put my meter on a high scale. But if we drop down here to my low scales, then eventually we should see a voltage on a solid state sensor, right?
Mm-hmm.
Okay. All right, now I need to turn it on. So here it comes on. And there, why don't we measure 114 volts?
We got 111.
Got 111, 112 volts. We got 112. Why don't I measure 114? I'm listening.
Because the sensor dropped 2.5.
Exactly right. Thank you, Riston. Because the sensor dropped 2.5, right? And it's a series circuit. According to Kirchhoff's law, the sums of the voltage have to equal to the applied voltage. So good catch. So that's so off we measured basically 0, right? If we kept it on a 120 volt scale, and then when the load was on, we measured 111 point what? 112 volts.
Mm-hmm.
Okay, so I've already got my I checked that off. Going to turn the power off, but I went ahead and wired my ammeter anyway. So it's already in the circuit. So this is my red meter. Let me get it up here so we can see it. I got my camera to make sure it's seeable. Let me change the tilt a little way to keep the glare off of it. Okay. All right. So we're going to measure current. Okay, so we're going to start off with the load on. The load on. So what's it measuring? Oops, sorry. I got too close. My glove touched it and it can't retro reflect, so let me. So what we measuring? I can't see, guys.
21.4
milliamps, yeah.
Yeah, 21.4. Yeah. So which number is that?
This is with the load on, so this is 8A.
I'm confused.
I'm sorry, 6. I can't. I'm standing up, guys. I can't read my thing. I'm thinking about. Let me change. This is 6A. Thank you, Jalen.
So, you're welcome.
I couldn't see the lab. This is 6A, 21.4 milliamps. And this is with it off. So what I'm gonna have to do is I'm gonna have to, I know there's leakage current because it's a solid state sensor. So let me turn this down. And this is a lot less. This is only doing 1.8 microamps. So you need to erase the milliamp and put what? Microamps. Why is this so much slower than the 2-wire sensor?
Wait, so this right here, the second reading is B, right?
Yeah, this is B. This is our leakage current. So B and 14 is the same. It's just like before. This is our leakage current. The leakage current is how much current gets through the solid state sensor when it's turned off. So right now it's off, and we're measuring 1.8.
So it's 180.
No, that's micro. This is microamps. It's 1.8 microamps. So my meter is measuring microamps. So you need to mark out the milli and make that what? Micro.
Micro.
And you need to do that on 14. Why is it so much lower? A while ago it was 300 and something. No, I'm sorry, 300 to 600. Well, it was 300 or 600 microamps. This guy right here only needs 1.8 mil. This guy here's only got 1.8 milliamps of leakage current. Can somebody tell me why? So I guess Rich is going to have to answer that, right? So this guy, this was the first one we started up through. And then we came over here and we had a light. Now this is in series, so we have to get enough current flow through this thing to make it operate, right? You understand that? So what happens is that this guy's got to have more leakage current because this is the current that's making the sensor operate, right? We got to have enough current to make it operate. Over here, this is a 3-wire sensor. The current that makes it operate is not required by the load anymore. So the current that makes it operate is here. Over here, the current that makes it operate is here. So these 2-wire sensors they're going to have more leakage current through them than what? Than a 3-wire sensor, because the 3-wire sensor don't need current. It gets current through L1 and L2 to operate. Now the leakage current now is leakage current. So basically, that leakage current we measured before would be the minimum operating current. Over here, though, the operating current is fed through here. So what we measured here is 1.8 microamps. What we measured up here, I can't remember. It was either 300 and something or it was 600 and something, but it was still microamps. I can't remember. I have to go back and look. Y'all were supposed to record that.
631 milliamps.
Not leakage current. That's milliamps. That's over half an amp. That can't be right. Your leakage current is always going to be.
So that 1.8 microamps.
What's that?
On this one, 1.8.
Not million, micro
Oh, thank you. Yeah.
631 microamps.
Yeah. So the leakage current, the operating current is going to be in the microamps, except here, here's the operating current here, and we're not going to measure that. So this only has 1.8 microamps worth of leakage current. So your 3-wire sensors, they drop less voltage. So up here, this guy here dropped 4.6 because it's got to generate enough power to operate. This guy right here dropped 2.5. So these guys, we really got to be cognitive of how many we put in series, right? Because they drop almost 5 volts. This guy right here drops around 2.5. So in a 120 volt circuit, we could put a lot of these guys. Turn off the power. With the power off, take the circuit apart. And we're not going to hook up the motor. We're just going to put our... we'll turn off the circuit. Come up here and take my... let me let y'all see what I'm doing. Let me put the camera, the right camera back up there. This shouldn't take too long because we're just going to swap out a couple parts. So I'm going to take out the light, take off the lights. Well, let me look at the circuit and make sure before I start tearing it apart. Yeah, it's the same as the last one, but it's going to use a... So I'm going to take out the lights. I'm going to put a control relay in. We're going to take the output of the sensor, which is this guy, and I'm going to hook it up to 13. I'm going to take L2, hook it up to 14. And I'm going to take my magnetic motor starter. Need to take my gloves off while I'm wearing this. Then I'm going to take 5 and run it to 10. And what else do I need? I need L2. And L2, where can I get L2 at? I'll get L2 right here. Went to 9. So L2 goes to here, goes to here, goes to there. Okay. I'll turn power back on. See if the circuit is working. No. Oh, okay. Nine to L1. Okay. Forgot my L1 on my control relay. Okay, so got my circuit hooked up. That didn't take too long, did it, guys?
Nah.
So down here on my control relay, this is 13 and this is 14. My relay contact, this is 9. This is 5, and then my motor starter, This is 10, and then this over here is 9. However, after put on your required PPE after wiring has been approved. Turn on the supply voltage. Place your hand in front of the photoelectric sensor. The control relay and motor starter should turn on. Remove your hand from front of the photoelectric switch. The control relay and motor starter should go off. And that's all we need to do here. So we're just going to watch it operate. So here, you're not going to be able to see it. You can hear it though. Hopefully y'all can hear the, so I can stand in front of it here and y'all can hear the motor starter come in. Of course, the control relay, if the control relay doesn't come in, then the motor starter's not going to come in, right? If I get too close, it don't get retroreflective. Okay, guys, what I'm going to do is I'm going to get the retroreflector, which you don't tell us to do, but we're going to do it anyway. And I'm going to put it here. So this thing is true. Can y'all hear the relay? And now when I move something in between it.
Yeah.
So this is working opposite. So here, retroreflective starts off true, which is on our motor starter, and then we come up here, and then when we break the beam, it goes false. Y'all see that? All right, guys, I know y'all can't see me, but and y'all might not be able. So here. Let's see how far I can get. I'm going to run out of space. Can y'all see where I'm at? I can't see y'all. So what, I'm about 5 feet away. If this guy's, I don't have to line it correctly. It's still working. I guess I'm about 10 feet. And I don't have to be perfectly aligned, right? And I'm going to run out of room. So this retroreflective, my retroreflective has, it looks like it's at least 10 feet range that we can set them up. This is what they have down at the bookstore. Used to anyways. I don't think I've been down to the bookstore. But diffuse is a very limited range, right? Because it's dependent on reflective light. Retroreflective, though, we have a lot longer range because it's reflecting not from an object, it's reflecting from a retroreflector. And notice I didn't have to line it up. I could actually get out a little bit to get it to go past the relays. And I got all the way back over here. These guys right here are, I think, 5 or 6 feet, I can't remember. So I was a good 8 feet away, and this thing was still working. But the through the beam has the ability to have the longest range because it doesn't reflect back off anything. It just goes from transmitter to receiver. So what's nice about a diffuse sensor is most of the time we can also use that diffuse sensor as a retroreflective, right? Y'all understand that? And we just have to change the way the contacts are inside our control program. So guys, so when are these going to be due?
Midnight.
Before the start of next class.
Wednesday.
Before the start of next class.
That's even better. Yeah.
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 It's just like regular time because y'all got to do what? Y'all got to answer these questions, right? I want y'all to draw the circuits out. They're not very complicated, and I want you to put those manufacturer numbers on there. Y'all want me to go back and call them out?
Shoot.
Yeah, go ahead.
Are we ready?
You got to draw them out.
You got to draw them out. I gotta do something to make y'all earn y'all's grade, right? So let's see how good y'all can draw.
Rich
let me-
don't play.
Let me go back to the very
Exactly.
first. I'm gonna go back to the very first circuit. But how long would it took y'all to wire those circuits up?
Well,
Forever.
Tell the truth.
I don't know. That's pretty fast in motor control.
Yeah, I know. That was less than 15 minutes, though, guys. But yeah, these are not. These circuits right here are pretty simple. What we'll do, what we'll do Wednesday is, by the way, I'm fixing to get out of the collaborate. Y'all can talk to each other and collaborate if y'all need to. I'm fixing to get out of this because this is the end of what we're going to do today. So y'all still got about 30, 40 minutes that y'all can collaborate with each other. But what was this one? This was 2. So this is lab 1.
What was 2? The one connected to L1?
Yeah, so the one connected to L1 was 2 because then the one connected to the load was what? It was 1. Remember, we did the standard color code. Then my lamp is what? 1 and 2, right? I put 1 on the L1 side and I put 2 on the L2 side. So that's a pretty simple drawing there. Are y'all okay? Can I move on?
yeah, I already drew it.
Okay. Yeah, I'm gonna be interested to see these drawings. This is a little more complicated. This is still what? This is still 2. This is still 1.
2 and 1.
Now my control relay, this is 13. So 13 is pointing toward the L1 side. 14's on the L2 side. Are we okay?
Yeah.
Down here on my contact, I'm using 9 on L1. 5 pointing toward the motor starter. So 9 and 5. This is 10 on my motor starter. And this is 9 over here on the other side of the overloads. And we don't get access to this wire right here, so this is 9 over here. Are we okay?
Yeah.
Everybody okay besides Jalen? Jalen's okay.
If I just print it out and write it, you want me to take a picture of it? So
Yeah, that's fine. If you want to print this
Okay.
out and then draw, and that'd be fine. Be fine.
Okay.
Now on 2, this is almost exactly the same. It's exactly the same except we added 1 more wire. So these are right. Y'all don't have to do these, guys. These are right. So this right here would be 3. So the only thing you got to put is 1 and 2. Are we okay?
Yeah.
And then this right
Go
here
back
is
to it right quick.
what, Sancho?
Hold on. Alright, you good.
And what we're saying, the circuits are basically the same past the sensor. So this is my control relay. This right here is going to be 13. This is going to be 14. I'm using the same contacts. I'm using 9 and 5. This is 10. And this is 9. So what we'll do next class, we'll probably do that virtual lab again. We're going to do a potentiometer lab. We all have to do a little math. Y'all can start looking that over. And then we're going to do our design project. And I'll pick which one of your circuits that I'm going to use. And no, you don't get extra points if I use your circuit. I knew that question was coming. So we'll leave the collaborate session open. The collaborate session will be open up till I think 1 o'clock. So y'all can collaborate with each other, but I'm fixing to back out. So if y'all got any questions now, y'all need to let me know.
Hey, when are you gonna post the recording?
I'll try to look and I'll try to do it tonight when I get home. I'll try to do that, but I'll have to do it
Will you
today.
send out a courtesy text to let us know when it?
Yeah, I'll send out. Like
when
that's
it's
what I've been doing, right? I've been sending y'all out a text when the recording has been available. Yeah. Okay. Any more questions?
Capri.
Okay.
What's
I'm
up?
gonna stop the recording.